Okay. So the probability that I take medicine and I'm cured will be 1/2 times 3/5. And multiplying fractions is easy because you don't need a common denominator. So you just multiply the 1 times the 3 and the 2 times the 5 and make sure that your answer is in simplest form. So overall, if I'm entering this study, I have a 3 in 10 chance of taking medicine and being cured. Okay, the next one is the probability that I take a sugar pill and I'm cured. So the probability I take a sugar pill is 1/2. And then the probability that I then am cured is 1 out of 10. So it's going to be 1/2 times 1 out of 10. 1 out of what? 1 out of 20. Thank you. Okay. If I want to know the probability that I'm going to be cured, it's going to be bigger than 3 out of 10 because this is just medicine and cured. And it's going to be bigger than sugar pill and cured because this is just sugar pill cured. So all you have to do is add these two probabilities together, and that will tell me the probability of being cured. So the probability of being cured is the sum of all probabilities that end with being cured. Or that result in being cured. Okay, so the only ways to be cured are medicine cured and sugar pill cured. And so it's going to be 3/5 plus 1/10. Yeah. Yes, so your final answer should be simplified. That's good. You can add those fractions in Desmos. You cannot just add them the way they are, though. So you could put it in Desmos, and Desmos will figure out common denominator for you. But when we're adding, remember, we need a common denominator. And so I can make both denominators 10 if I multiply the first fraction by how much? 2. By 2. So if I multiply this one by 2 over 2, I would get 6 over 10 plus 1 over 10. So you're close. So when you add and subtract, you need that common denominator, and then you keep your common denominator. You don't add the denominators, only the numerators. Okay? So we keep our denominator at 10, and then we're going to add our numerators. Now, it is really helpful to be able to add and subtract fractions in real life, but in class, if you feel like that's tripping you up, you can use Desmos. Okay? So the sum of being cured in this study is 7 out of 10. That's not bad. If I was looking to be cured, I might try that study. Not bad. Sorry, guys. I'm going to say that one more time because I didn't record it. But if you don't have this yet, please draw it. So on the first time we spun the spinner, we got either 1, 2, or 3. And then after we get one of those results, we spin it again, and we again can get 1 or 2 or 3 after each one. If I spun it a third time, I would be running out of space because I would have to do 1, 2, 3 on each number again. All right, what is the probability that I'm going to land on the number 1 the first time I spin it? It's a fraction. What is it going to be? 1/3. It is 1/3. Good. So I have a 1/3 chance of landing on the 1. And how about, what's my chance of landing on 2? Still 1/3. Thank you. And the same thing with 3. So I have a 1/3 chance of getting each number. When I spin it the second time, the spinner has not changed at all, so it's still going to be 1/3. So everybody gets a 1/3. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. Okay, let me try to zoom in on that a little bit because that's a little bit hard to see. But basically, I put 1/3 on every single branch because no matter how many times I spin it, it's still going to be a 1/3 chance of each number. All right, I want you to try to find the probability that you get 2 3s in a row. So that means that you went here, you got, yes. So that's a 3, and then that's a 3. Follow the tree and multiply your fractions to find the probability you get 2 3s in a row. I'm going to wait for you guys to write that on your paper and then find your answer. The probability of getting a 3 is 1/3, right? 1/3. What's the probability of getting another 3 after that? Still 1/3, yeah. So when I multiply them, I'm going to get 1 out of what? 1 out of 9. Very good. So I only have a 1 in 9 chance of getting 2 3s in a row. All right, I need to find the probability that the numbers add up to 4. How many ways can I add up to 4? It could be 1 and 3, or it could be what? What other numbers add up to 4 besides 1 and 3? Guys, learning works best when you do the thinking. The two numbers have to add up to 4. So it could be 1 and 3, or it could be what? 2 and what makes 4? 2, good. 2 and 2. So it could be 1 and 3, it could be 2 and 2, or it could be 3 and 1. Okay? So I'm going to write that as a note. Could be 1 and 3. Could be 2 and 2. Or it could be 3 and 1. Oops, so there's 3 ways to do that. All right, 1 and 3. That would be 1/3 times 1/3. That's probability of getting 1 and 3. 2 and 2. That's also 1/3 times 1/3. And then 3 and 1 is also 1/3 times 1/3. All right, so I had to find the probability of each of the possible ways to do it and then add them up. So we already know 1/3 times 1/3 is how much? We just did it in the last problem. What did we get? 1/9, yeah. So this is going to be 1/9, this is going to be 1/9, and this is going to be 1/9. All right, so 1/9 plus 1/9 plus 1/9 gives me how many ninths? 1/9 plus 1/9 plus 1/9 is 3, right? 1, 1, 1. So 3/9, which does simplify to 1/3. Whoops, there we go. All right, I'm going to pause so you can think about that. Okay, the probability that you get any number twice. So 1 and 1 is a possibility. Sorry, up here. 1 and 1, 2 and 2, or 3 and 3. Can anybody make a prediction about what that answer is going to be? 1 and 1, 2 and 2, or 3 and 3? Does it sound like we're going to approach it similar to how we did A or B? Okay, let's start it, and then you can tell me if you want to predict the answer before we even finish it. The probability of getting a 1 is 1/3. And then the probability of getting another 1 is still what? 1/3, yep. Eric, what's the probability of getting a 2? What fraction is the only fraction we see on here? 1/3. Yeah. So the probability of getting a 2 is 1/3. And the probability of getting another 2 is also 1/3. All right, so this is the probability of getting 1 then 1. This is the probability of getting 2 then 2. And now we have to do the probability of getting 3 and then 3, because we're trying to find the probability of getting the same number twice. So the probability of getting 3 and 3. So that setup is exactly the same as the setup for which other problem? Problem B, yes. So instead of doing the exact same long steps over again, now that we see the same exact setup, we can predict that the answer will be how much? Taken? 1 over, same as this one, right? 1/3. I'm choosing from the hat. What are the possible colors I could get? Okay, so the colors I could get are either red or green, right? All right, if you haven't put that on your tree diagram yet, put that now, please. All right, and then after you choose the first time, then again, you might get red or green. So it could be red, red, or red, green. And after I choose a green one, I could have still another red or another green. Okay, so those are the possible outcomes. Red, 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 green. Green, red, green, green. Okay, there are 7 red and 3 green balls. Arturo, if there are 7 red and 3 green balls, what's the probability that one that we take out is going to be red? 7 out of how many balls altogether? 10, good. You guys see that? 7 red out of 10 altogether. And then Aisha, if there's a 7 out of 10 chance of getting a red, what's the chance of getting a green? 3 out of 10. Okay, but remember, this time I told you the probabilities will change because once we get that first ball, we take it out. So in the first situation up here, we chose a red ball. So Emmeline, if we chose a red ball, we no longer have 7 reds. How many do we have? Good. So the probability of getting a second red ball is 6 out of, we no longer have 10. We have how many? 9. Good. Okay, so that's because we took one of the red balls out. Now, the probability of getting red-green, we still have 3 green balls. We still have 3 green balls, but we only had how many total after we took one out? So we didn't take a second one out. We just took that first one out, so it's 9. Yeah, I can see where that would be a confusing thing to ask. 3 out of 9. Okay. I'm going to take your question in just one sec. I want you guys to figure out this part. Were you going to ask me what it was? Were you going to suggest an answer? It's a good question. In this case, we took a red ball out right here. Okay? So if we took a red ball out, we still have 3 green. But then when we come down here, when we take a green one out, then it's going to be. So you're predicting what you're about to do. That's very good. The second time we choose, we've already taken a green ball out, so they both have a denominator of 9. Okay, so I took a green ball out right here, and there's only 9 balls altogether. But I still have how many reds? In this case, I took a green one out, so I still have how many reds? 7, yes. So in this case, because I took green out, I have 7 reds. But, Emmeline, I only have how many greens? 2, right, because I took a green ball out. Okay. I want you to find the probability that both of the balls are red now. So you're going to have to multiply the probability that the first one is red times the probability that the second one is red. Okay, probability that the first one is red is this one right here, 7 out of 10. And then after you chose that one, you want to find the probability that the next one is red. I don't use this one because that one came out of green. That never happened. So first one is red here, and then second one is red here. Okay. Who has a question about why I chose those fractions? Okay, so now I'm going to multiply them, 42 over 90. And then we have to simplify it. And you can simplify in Desmos or in your head. Let's see, I think I can divide them both by 6. So I'll get 7 over 15. Did you guys get the same? You got that? Okay. All right, questions on that one before we do our last one? Last one. Probability that they're different colors. So different colors could be red, green, or it could be green, red. So we're going to write that down. Red, green, plus green, red. All right. Red, green, 7 over 10 times 3 over 9. Plus green, red, 3 over 10 times 7 over 9. Whoops. Okay. So they both end up being 21 over 90. So I already have a common denominator. When you have a common denominator, you do not add the denominators, you keep it, but you add the numerators. And it turns out we have that same probability, which is 7 over 15. That was just a coincidence. Okay, so you have a 7 over 15 chance that you're going to get red, red, and you have a 7 over 15 chance that you're going to get 2 different colors.